Okay. All right. So, hi Prisha. Hey Sunarka.
Hi, sir.
Okay. 8 minutes. So let's do a quick roll call and then we'll get started. So we have Aryan, Dev, Dhanushri, Chris, Prisha, Rehan, Srivatsav, Sunarka, Vihan, and Vishal. Some kids are still missing, but they will join. And here in the classroom we have Puneet. So, as I have mentioned before, we have started the second iteration of the entire syllabus. So right now we are in Unit 2. So Shravya.
Hi, sir.
So we have started Unit 2 from today, or we are starting Unit 2 from today, and I just mentioned or shared with you guys what are the topics that we're going to cover in the class today. So these are primarily we are going to talk about ratios, rates, proportions, unit conversions, percentages, then center spread and shape of distribution. So we'll start with ratio, rates, proportions, and then we'll go to percentage and then unit conversion and center spread. So first of all, some of you will find it very easy because this is not something that you're going to learn afresh. Two reasons. One is we have covered it in the past. Yes, Ryan.
Hi, sir.
Here, just so hello. So as I was saying, so we are starting Unit 2 from today. Unit 2 as in Unit 2 of Khan Academy. All of you who don't know, search up for Khan Academy, go to Digital City Prep, and that is where the Unit 2 is what I'm talking about. So we'll start with ratio, rates and percentages, then we'll talk about unit conversion, and then we'll go to center, spread and shape of distributions. So first of all, when you talk about ratios, rates and proportions, what exactly comes to our mind? Ratio, A to B, A is to B, or A by B. This is one representation of ratio. When you're comparing one number against the other number, right? So be it ratio, be it rate, be it percentage, everything is a relative term, as we all understand. Here, when you talk about ratio, A is to B, or you can say B is to A, meaning B in comparison to A, or A in comparison to B. Okay, so that is how it is represented here. When you say A is to B or A by B, you are essentially saying you are comparing A against B. Is this fine? Whichever is your denominator, whichever is at the bottom, that becomes your base. And I'll explain to you why I'm saying so. Yeah? But is this understanding fine? Yeah. Now, this is ratio. Now, you will say, how about rates? Rates is also the same thing, a comparative scale. If you say 50 miles per hour, this is a representation for rate. You are talking about the speed at which something is moving, be it your car, be it you running yourself. I mean, I wish one of you can run this fast to beat the record of Usain Bolt. I think the fastest he ran was like 30 miles per hour. That's what it will be, right? So this is nothing but rate. Again, when you look at rate also, it is some compared against a base. Your base is hour. Per hour how much? If you talk about price of tomato, you will say $3 per pound. So this is your base. You're finding out your price against a base, which is nothing but your weight for which you are trying to get the price. So I see there is one more child has joined, and that is Mary Zan. can you introduce yourself better quickly? Somebody with name Mary?
It's my daughter Tavisha. She
Oh.
just joined Jansi.
Yes. Okay.
Yeah, like
Good. So what's your name, beta? One more time.
Tavisha. One
Ta-
minute. She's
Tabisha. Okay. Yeah. Can you hear me okay, Tabisha? I hope I'm pronouncing your name right. Okay. All right. So a quick introduction for Tabisha. This is your first class, so that's why there's something that you need to know. Whatever we do in the class, this is for SAT preparation, where we have kids from 9th grade all the way to 11th grade, and we follow Khan Academy as a base to understand each and every concept that we need to be prepared with for SAT exam. So we have in this group we have done one iteration of all the 13 units that we have as part of SAT syllabus, and we have started second iteration. So that's why we are starting with unit 2 today, and you have joined with not much of a delay. So basically, you'll be able to go through all the concepts that we have to learn in next 5 to 6 months. One more iteration of entire unit of entire syllabus of SAT that we will do. Okay. And whatever we do in the class, that is getting recorded, not your screen. It's only me and the board that is getting recorded. So I upload that in YouTube so that you guys have something for your reference. So when I'm teaching, I would request everybody in the class to pay attention to understanding the concepts rather than being busy taking notes. Because notes you don't have to take. You always have a video of the class for your reference on. Okay? Alright? Alright. So we are starting with unit 2, which is ratios, rates and proportions. And then we'll talk about data, statistics, probability and everything. Okay? That is part of unit 2. So we just started with the point that what is our understanding of ratios, rates, proportions, and then we'll extend further and then we'll talk about percentage also. And most of these things you guys would know. I'm just trying to give you guys a little different perspective or a way to interpret that in a simpler way. Okay? And if you find what we are doing in the class has some merit into it, you can probably inherit that. So what I'm saying is, all these 4 terms that we talk about, this is where we are not talking about any value in isolation. It's always in a relative form. If you talk about ratio, you're saying A to B, meaning A is compared against the base B, meaning how big or small is A compared to B. Or if you say B is to A, you're saying how big or small B is compared to A. Is that a fair way to start? Everybody?
Yeah.
Stop looking at other stuff.
Sorry? Vishal saying something?
Nothing.
Okay. Alright. So this is the understanding of ratio, and we'll talk about it. Let's say somebody says, you guys are much younger than me. So if you say, let's say Pranit's to my age ratio between Pranit's age and my age. So it's like Pranit's age versus teacher's age. When you look at this ratio, you are essentially looking at Pranit is probably what? 13, 14 years? 14. So 14 is to the $1 million question. Yeah? So Pranit to my age ratio, meaning here the way you will read it, Pranit's age compared to my age. Almost like 1/4. Yeah? However, if I say teacher's age to Pranit's age, teacher is not 14. I wish I was. Yeah. Now when you look at this, this ratio gets more interesting because you're talking about 48 divided by 14, meaning how much is the age of the teacher, or how big or small is the age of the teacher compared to Pranit's age. And this is where you see it's almost like 3.5 times. So it gives you a view that when you are talking about two numbers, how big or small is one number compared to the other number. Is that okay? Now let's go to the next step. Now I'm saying here in this case, what did we see? We are comparing one number against the other number, which is supposedly our base. Now when you talk about rates, here my age and Pranit's age both had the same unit. My age was in years, Pranit's age was in years. When it comes to rates, you look at it a little differently, where the unit changes. Here if I say price of, let's say, potatoes, $3 per pound, or speed of the car, 70 miles per hour, or let's say salary of an IT professional in the early time of the career, let's say $5,000 per month. Okay, so if you look at these values here carefully, these are rates. This is the rate at which you can buy potatoes. This is the rate at which your car is moving. This is the rate at which somebody is paid. Yeah. So the main difference, the most important or significant difference that you will see between ratio and rates is, here also you are comparing. In case of rates also you are comparing, but in the case of rates, you are comparing one unit against another unit. In case of ratio, your unit remains the same. When I am talking about ratio, I would not say number of hours in a day compared to price of potato per pound. Here, both the units are same, or the units used for both the quantity are same. Here, you will see that your units are different. So basically, when you are talking about rate, you are looking at comparing your value against a different unit. There is no similarity or correlation between dollar and month. Okay, and most of the scenarios, it ends up being per unit thing. Be it the price of potato, be it the salary, be it the speed. You're talking about per unit. Mostly it's in time, except for the things when you are buying, purchasing something. So, I mean, ratio and rates might look similar, might sound similar, but when you are looking at how do you kind of keep them separate, this is one striking difference that you would want to take into account, that when you are talking about rates, you are talking about two different units. When you are talking about ratio, they are using the same unit. Is that part clear? Yeah. Now comes proportion, and the most classic example is, and people who can appreciate this would be the people who have entered kitchen a couple of times. I mean, to be able to relate it more practically. Let's say if you want to make a cake. Okay, my cakes are always round. I mean, I don't make cake, but I'm saying the way I will visualize that is, my cake is round. If I'm trying to make a small cake versus a big cake with the same flavor, I don't want to change how it tastes, or I would not want to bring any difference with respect to taste of one slice here versus a slice here. Meaning, I'm trying to make sure my quality is the same. What we have to take into account here while making cake, all of you who have made cake or even who know how to do cooking, the most important thing that you have to take into account is the proportion, the relationship between the ingredients. Let's say 1 cup of flour goes well with 1 egg, okay, while making cake. If I take 1 cup of flour and put 5 eggs into it, just trying being more generous, that is when I'll mess up the outcome. My cake might go for a toss. People would not appreciate me as a good cook or a baker. So what is important here? You are saying that there is a relationship between these two ingredients. Okay? Or you would have heard about teacher to student ratio. If you have a class, one teacher for 20 students versus one teacher for 70 students. In this case, what we are compromising is quality of education. The kids might not be able to follow, or the teacher might not be able to give proper attention to all the kids. So here, this ratio or the relationship between the two parties or two participants or two ingredients, that is where ratio comes into picture. Let's say if you have one teacher does good with 20 students, so if you have 70 students, that means you need at least 3 or maybe 4 teachers basically. That is how you will be able to make sure that you are paying attention to each and every student in the class and everybody is able to follow the concepts. So now if you relate ratio, rates and proportion together, the first derivation or the derivation that we should have in mind is ratio is where you are comparing one number against another number. And you can flip the ratio and see 1 versus second versus first. Okay. When you talk about rates, you are essentially looking at the per unit thing, be it in terms of speed, be it in terms of price, be it in terms of any other calculation where you are comparing it against a certain unit. Let's say if I say a child grows 5 inches per every 2 years. So here, growth is compared against time. 90% of scenarios, when you talk about rates, it's mostly against time, except for the case when you are talking about price. Okay, where you are trying to find out the per unit price. Or there could be scenarios where you talk about one tap. I don't know if it looks like a tap. Okay, fills a tub in 3 hours. So here you are talking about the rate at which water is filling the tank. And so if I have one tap which fills the tank in 3 hours, if I put 3 taps, how many hours it will take? So all that calculation, essentially the main thing is you have numerator using a different unit and your denominator using a different unit. And 80-90% cases it will be against time, but whenever you are dealing with pricing, that is where you will have weight or other units coming into play. And when we see more examples, we'll come across this. Are you guys with me so far? Am I confusing you guys or you are okay to relate?
Yes.
Now, the next thing that we learned was proportion, where we talked about a relationship between two things. If you're talking about a composite situation where you have ingredient 1 and ingredient 2, what is the relationship between them which works the best given what you're trying to get? Let's say if you're making vegetables, if you're making curry, let's say, again, everybody in this class understands what is a curry. So if you're making curry and you know that for, let's say, 2 pound of 2 pound quantity of vegetables, you would probably need half a teaspoon of turmeric. And if you are in a mood to do adventure, you put 5 teaspoons of turmeric. You can imagine how good or bad the curry will taste, right? So these are the scenarios where the relationship between two ingredients or two participants or two parties matter. That is where we talk about proportion. Here you are just comparing them. Here you are relating them. That's one major difference. Yeah. Here A by B, if it is 1 by 8 or 2 by 9, doesn't matter. Here it matters. So that's one of the difference. Preet, are you okay? Yeah. Not unwell, right?
No, it was yesterday.
Ah, okay. Yeah. If you're feeling cool, I can close it. Yeah. Alright. So we just saw some examples, or we just tried understanding what is ratio, what is rates, and what is proportion. Everybody with me so far? Okay. Alright. Now let's go to the next step where we will talk about percentage, and then we'll look at some problems to see how easy or difficult those are to relate and apply whatever we learn. Okay. So if I talk about percentage, what is a percentage? Percentage is nothing but an extension of ratio. Now if you recall, when I was saying what is a ratio? Ratio is a way to compare one number against another base. Okay? So if I say, now let me take the same example. This time it's not Pranit. Let's say this is Dev. Dev, I don't know how old are you, but I'm assuming you're 14 years old. I'm just assuming, okay? And don't get offended if I put yes more or less. Here, when I'm looking at 14 is to 48, meaning Dev's age versus my age, here you are comparing Dev's age against my age. So this is a ratio, and you know how to convert this into a decimal, and you'll say, okay, Dev's age is to my age is this by this, or it probably comes down to something like 0.3 or something. Okay, whatever it is. So you know this ratio you can represent in the form of decimal. There's another way in which you can represent that, and that is called percentage. Percentage. Yeah? Or percent, whatever you call it. So, percent everybody would have heard at least 5,000 times. There's nothing new that I'm teaching you guys today. But if you look at percentage, it has two parts to it, per and cent. Per is per, $50 per hour, this per, for every, and cent, per I will put as every, and cent is nothing but short form of century, which stands for 100. So per 100, when you talk about percent, you are essentially talking about for every 100 how much. So if I say if I tell you guys that during the Thanksgiving, when I was trying to buy a shoe, they were saying there's a 15% discount. Okay? I picked up a shoe which was priced at $80. How much do I have to pay? The way you will relate it, I know you all are getting tempted to solve it. I'm just giving you guys a theory, and then obviously we'll look at some problems. 15%. So the simplest way you will think about it, okay, for every dollar, for every 100%, 15%, 15 per century, 15 for every 100. Okay? Meaning, for every 100, there's a discount of $50. I picked up something which is worth $80. If I would have picked up something which is priced at $100, it's very easy. I know that I'll get a $15 discount. Because it says for every 100 you'll get $15 discount. That means for every 100 I'm getting $15 discount. What if I picked up something which is priced at $1? I'll get 50 divided by 100. I had 1 into 100, so I just kept 1 here and 100 came down. If I pick up something which is priced at 80, So it will be 80 times the value of $1 or 80 times what I'm getting for $1. So 80 times what I'm getting for $1. And you know how the calculation works. Now, there's another way of looking at it. So far I'm not teaching math, I'm only talking about English, okay? What we're trying to find out, how much, my discount offer is 15%. So how much is 15% for $80? So 15% of 80. So this is not math. This is, you're just talking out loud to calculate a percentage. 15 per, you obviously right, 70 miles per hour. So miles in the numerator, hour in the denominator. So I'm saying 15 per century or cent off. Into is also off, right? So 15% of 80. And this is how you calculate. So tomorrow, if you have to say, find out 30% of 200, meaning you picked up a shoe which is priced at $200 and you're getting 30% discount. How much discount you're getting? So 30%. So you're saying 30% of 200. And then you do the calculation the way you want to do. Yeah. So percentage which comes out, sometimes we get baffled by while trying to do calculation. It is actually a very simple form of English. There is nothing complicated here. Now, I'm pretty sure none of you will make any mistake when it comes to finding out the percentage of any given number. If I talk about situation or give you a word problem, I'll say, whatever salary I get, I am giving 60% of that for a social cause. And that's true. So whatever I'm getting from you guys for teaching you, I mean not from you guys, from your parents, 60% of that goes for a social cause or for supporting the poor kids back in India. So, and I'm not disclosing how much I'm getting. Okay? So I'm saying whatever I'm earning by doing what I'm doing, 60% of that goes for doing a social cause. Okay? So this is a word problem. I'm saying 60% of whatever, I don't know how much it is going for the social cause. If I add another $1,000 to that, I will be able to buy let's say I will be able to buy kitchen set, or I will be able to remodel my whole kitchen, which needs, let's say, $3,000. I'm saying, tell me how much I'm making by teaching you guys. Again, and this is just an assumed number, okay? I'm not making this much, by the way. So what I'm saying is, whatever I earn by teaching you guys, 60% of that goes for a social cause. Whatever goes for the social cause, if I add $1,000 more to it, this money would be enough for me to revamp my kitchen, which needs $3,000. Tell me how much I'm making by teaching you guys. Who can give it a shot?
Are we just trying to find X?
Yes. I mean, again, I'm not saying what I'm trying to find out. We are trying to find out how much money I'm making by teaching you guys. So I said 60% of whatever I'm earning by teaching you guys, 60% of that goes for a social cause. Whatever goes for the social cause, if I add $1,000 to it, that will be enough for me to revamp my kitchen, which needs.
So are you saying X is the social cause number?
I will not give you guys clue. I will stick to my forceful setup where I say tran, right? Because when you get a question in the question paper, You only see the question. There is nobody to explain that question, right? So I'm just forcing you guys to think on those lines. Let me read the question one more time because that's what you'll have in the exam. I'm saying what I make certain money by teaching kids. Whatever money I make, 60% of that goes for a social cause. Okay? Whatever money I spend for the social cause, if I add $1,000 to it, that'll be enough for me to remodel my kitchen, which needs this much money. Now tell me how much money I'm making by teaching you guys. And if you guys want, I can read that question one more time. Did everybody hear the question in the first place? Yes, we have.
So you're asking how much you make?
By teaching, yes. And again, this is just an assumed number for solving math, okay? I mean, no, you should not be holding me accountable for promising that number. This is just a question, okay?
So as far as I can give my answer,
Yep.
it's 3,460, 3,466.
You're saying I'm making this much money by teaching you guys?
Yep.
Okay. So I'm reading the question one more time so that whoever could not hear it clearly, I'm saying that I make money by teaching kids on the weekends, and 60% of that money goes for a social cause. Whatever money I send for social cause, if I add $1,000 to it, that money would be enough for me to revamp my kitchen, which needs $3,000. Now what I'm trying to find out is how much money do I make by teaching kids? Everybody heard the question, right? Prisha, Vishal, Sunarka, Sian, everybody? Okay. So now I'm just waiting for one more answer. And then
Wait, can you change my answer? Because I thought that said 3,080. No, 3,000.
okay. Yes, Prisha.
I said $3,333.
$3,333. Okay. All right. Yeah, Chris.
Yeah, I got $3,333.
Vishal, you also got the same? Yeah, Vishal, go ahead. Tell me your answer before your teacher starts giving it a shot. Yeah, Vihan.
Yeah, I also got 3,000.
Okay. Aryan, how about you?
I also got 3,300.
Okay.
I got 3,333 too.
Wonderful. So I think you guys got the right answer, but as I always say, I will also do it one more time just to make sure that the way you guys solved it versus the way I would understand this question is on the same page. So let's look at it. I said 60% of whatever I earn goes for a social cause. And whatever goes for the social cause, if I add 1,000 to it, that will be enough for me to revamp my kitchen, which needs this much money. So let's, as I've already put in the question, X is the amount I'm assuming that is going for social cause. No, sorry. X is the amount. No, this is 60% of X. So 60% of my earning goes for social cause. That money added with 1,000 is 3,000. So let's say X is what I make. So 60% of that. 60% of X. And if I add 1,000 to it, this will be the money that I need for revamping my kitchen. Yep. Anil. Now, by doing this, so X times 60 by 100 will be equal to, this goes this side, this becomes 2,000. Or X becomes 2,000 into 100 by 60. 1 0 gone, 2 3 are 6, 2 5 are 10. This becomes 10, 2000 to 5, that is 10,000 by 3. So you guys got 3,333.33. So you guys excluded 33 cents, but that will be the right answer. Yeah. So again, one thumb rule for all of us to follow. Should I say one or two? Maybe two. One thumb rule is finding out percentage of any number is no big deal. If you have to find out certain percentage of any number, if you have let's say 10,000, and find out 8% of that. So this is just English. 8% of 10,000, and then you do the calculation the way you want to do. Okay. So this is easy. And then second thumb rule is my most boring strategy that I keep on forcing you guys to follow. You can ignore T. T is little tiring. Still, how do you run? Meaning, read the question couple of times, analyze, and then you try doing it. At least with the percentage problems, you will not have any problem as long as you have read the question enough, and then you have kind of put your thoughts together. Now, there is another flavor of problem that you will deal with when it comes to percentage. And again, I am not going to ratio and proportion problems because those will be pretty straightforward. My request to you guys would be try doing the unit test in Khan Academy for ratio, proportion, and other concepts along with percentages. And if you guys get stuck, if you come across any tricky word problem or anything that is not easy to not let me know. Then I can give you guys some approach, because calculation wise or mathematical capability wise, these are not difficult. You just have to approach it right, put your thoughts together, do enough scratch work before you start solving it. So that will be your thing. Try doing the unit test in Khan Academy, and if you get stuck anywhere, if you find some problem interesting, please feel free to share that in the group itself. Let's see if any of your friend is able to solve it. If not, your teacher is always there. Okay. Now, there is another flavor. Finding out certain percentage of a given number is no big deal. That's English. Let's say 300% of 80. It's the same thing. Be it 30% or be it 300%. Underlying concept doesn't change. So 300% of 80. And do the calculation. Yeah, that's okay. Now, a little tricky thing comes into place when you have to find out a number is what percentage of another number. That is where the concept of ratio helps you relate it, because ratio says you're comparing one number against the base, another base. If I say 30 is what percentage of 80? So 30 is what percentage of 80? Think about it like a ratio thing. You are comparing 30 with the base 80. You are trying to find out what is the existence of 30 when you are comparing this guy with 80. It's like a ratio scenario. This is your number that is in contention, and this is the base against which you are trying to evaluate a number. So think of this as a ratio, 30 by 80. You are comparing 30 against 80 and think what percentage. Since you are talking about percentage, meaning per 100, you will multiply that by 100. And that gives you the answer that you are looking for. So any number, if you have to find out what this number is, what percentage of another number, think of this as a ratio. And since you are talking about percent, for every 100, you just multiply that by 100. Now if you ask me, how did this come into picture? It's fairly straightforward. So let's say 30 is what percentage of 80? Now if you look at conceptually, per 100, you are saying 30 is what percent of 80? Meaning 30 is what percent? 30 is what per 100 of 80. Or the other way you will read it is 30 is how much when you are comparing that with 100. When your current base is 80. So you will say, okay, fine. When my value is 80, I'm talking about this number 30. Meaning for every 80, it is 30. How much will be the value per 100? For 80, the value is 30. For 1, it will be how much? 80 is nothing but 80 into 1. So for 1, it will be, you have to just simply divide by this number. You have to move this number out. It comes here. Now for every 1, it is 30 by 80. So for every 100, it is how much? 30 by 80 into 100. And this is exactly what we were seeing here. 30 is what percentage of 80? 30 is what percentage? 30 is what percentage of 80? So basically, this becomes your go-to approach to find out a number is what percentage of the number that you are trying to compare with. And conceptually, if you look at it, it just says that this value is, it is 30 for a value of 80. How much will be this value for a value of 100? This is what we are trying to determine. Okay? Alright? And this becomes your approach. Is this part okay so far from understanding point of view? Okay? Rehan, are you with me, beta? Ojas, Snarka, everybody? Dhanushri? Okay.
Yes.
Alright, so now let's grapple with this a little bit more. So hear the question clearly from me. Let me. I got $30. Let's say 40. Okay. I got $40 and my friend had 200% of what I had. Okay. I had $40. My friend had 200% of what I had. From whatever my friend had, he gave 60% back to me. How much money do I have now? I had $40 and my friend had 200% of what I had. My friend gave 60% of what he had back to me. How much value I have, how much dollar I have, how much money I have, and how much it increased by. I'm reading the question one more time and I'll keep reading it till you all have heard it, because I keep emphasizing, right, this is a very important part, so that's why I'm helping you guys read. I had $40 and my friend had 200% of what I had. My friend gave 60% of his money back to me. How much how much money do I have and how much percentage it increased by? Has everybody heard the question?
Can you do it again?
Okay, so I had $40 and my friend had 200% of what I had. My friend gave 60% of what he had. How much money do I have now? And by what percentage my value increased? Yes, Bihar.
So do you have $88 now, and your worth, like your money increased by 120%.
Okay, that is one answer. How about you, Vishal?
I got the same 88 and increased by 120% of the money.
Okay. How about you, Chris?
I think mine was wrong, but
No.
I
See
don't-
again. No. You have to tell me your answer. Okay. Right or wrong. Let's not conclude. Okay. Let's not worry about it. It's fine.
I think I got increased by 220%, but I'm pretty sure that's wrong.
Okay. While I'm waiting for others to give the answer, you can revalidate what you did. Yeah, Prisha.
I got $88 now and then 120% increase.
Okay. Anybody else? Ojas, Sarah, Shravya, Sivatsa.
Yeah, I got the same thing.
You got the same thing.
I got the same thing as well.
Dhanushri also got the same thing. Okay. Sunalka. Shreya.
Yeah, same thing.
Same thing. Okay. So let me just solve it one more time because no, I don't get that confidence without myself doing it, right? So I said I had $40, so this is me. My friend had 2% of what I had. Let's say my friend's name is F. Okay. So he had 2%, 200% of me, what I had. So 200% of my value. So he had, this becomes 80. So he had $80. So now we know he had $80. Next point that I made was that he gave 60% of what he had. So he gave 60%, let me write it like English so that I don't get you guys confused. 60% of what he had. So basically, he had 48. So he gave me 48. So I had 40 before, I got 48 more. So when you guys said my total worth was 40 plus 48, that is 88. That is correct. Now I said by what value my worth increased. So what is the total increase here? 40 to 88. So my total increase was 48. And 48 is what percentage? How much my value increased by? So I'm still trying to compare my increase with my base value, my original value. So this is my increase. So what is my increase compared to this number in terms of percentage, right? Like whatever we saw before. So this becomes this 4, 12, 48, 12 into 10, 120. So my worth increased by 120%. So you all were right when you gave me this answer. So Ravi, were you able to, Chris, were you able to verify?
Yeah, no, I see what I did wrong.
Okay. No, so that is why I keep on forcing you guys to do it, and without any fear, without any concern, without any doubt, you share a number. It's okay. I mean, this is not an exam. Nothing will go wrong, even if you make a mistake here. But it's important for us to know where I'm making mistake. So when you share it with confidence. Right or wrong, we'll figure it out. I mean, I did not approve anybody's number, right? I did not even trust anybody. Even if everybody said the same thing, I still had the courage to say, okay, fine, I will verify. I want everybody to have the same courage. It's okay. What I will get is what I will calculate in my exam, right? That's fine. So, I mean, I have seen situations where 5 people give the same answer, one person gives a different answer, and eventually the lone guy who has given a different answer ends up being right. So, never ever think of sharing if everybody is saying a different answer, okay? We'll figure it out. Now, so we looked at ratio, proportion, percentage, rates, we understood that. Now, let's look at a couple of problems with respect to rates, and then we'll go on to the unit conversion thing. So we might not be able to go to unit conversion, but I'll give you guys one assignment. Okay, I have one request for you guys. Make sure that you look at the units for distance, weight, and then volume. In US customary system, you should know the relationship. Just brush it up once, okay? So that tomorrow when we go through that, we can do it real good. It's not a big deal. Just a matter of knowing the relationship among different units within the same category of the measurement. Okay. So just brush it up once, okay? Because US metric system is much easier. There's only one song that does it all. And I'll talk about that song tomorrow. I'm not sure if I have sang that song before for you guys, but millicentidecimeter decahectokilometer. So just one song helps us with the volume, with the weight, with distance, and then it's only the US customary system where they are way too different, and we can use that for look at some quick problems. Sami, you have joined 9 minutes early. You will learn something that might be 5-6 years early for you. Okay, alright. So the next thing that you want to talk about was the rate. Where we talked about rate is nothing but when you're talking about your numerator being a different unit and the denominator being a different unit. Mostly we talk with respect to time, or sometimes with respect to weight or other things, depending on what we are trying to do with the calculation. So let's look at one simple example. One very common problem that I have probably come across at least 50 times during my childhood days, and I'm sure you guys would have come across a similar problem. I have a tank. Okay. I don't know what is the volume of the tank. Okay. I'm saying that I have one tap. Let me put, this is one tap. Okay. Assume this is a tap. This tap can fill the tank in 4 hours. Okay. I have another tap that can fill the tank in 3 hours. Okay. This tap can fill the tank in 4 hours. This tap can fill the tank in 3 hours. If I switch on both the taps, how long it will take to fill the tank? What would be your approach? What will be your thought process? Let's look at it this way. How would you approach this problem? I don't think we'll have enough time to solve it. But again, I'm repeating the question. I have a tank, and I'm not telling you guys what is the volume of the tank and all that. I'm saying I have one tap that can fill this in 4 hours. I have another tap that can fill this in 3 hours. So if I turn on only this tap, it will take me 4 hours to fill this up. If I keep this off and just turn this on, this guy will fill it up in 3 hours. Now I was in a hurry. I wanted to fill it up quickly. So I turned on both the taps together. More water flowing into the tank. I'm sure this will be filled very quickly, relatively faster. But how much that will be? Will it be 2 hours? Will it be 7 hours? Will it be 5 hours? And how would you solve it? What will be your approach for solving it? I mean, just tell me the approach. I'm not looking for an answer right now. If anybody can tell me the approach. So let me give you guys a clue, and leave you guys with that clue, okay? And then probably we'll talk about this in the next class, when we are talking about unit and conversion also. Any initial thoughts? I mean, I love talking to you guys, okay? So when I hear something from you, that gives me at least some insight into how you are approaching a problem. Sunarka, Savya, Shivatsab, anybody? Shreyan. And there's no wrong answer. Yeah, Chris.
So, what I thought about it, it was like one tank fills it up a third of the tank per hour, and
Okay.
the other fills it at a quarter of the tank per hour.
Okay.
So, you add them.
Uh-huh.
So a third plus a fourth, which gets you 7/12.
Okay.
Then you do 1 divided by 7/12, and then that's 12/7. So that's around 1.71 hours.
Okay. You got the answer also. Vishal, I was more interested in understanding the approach, but yeah, Vishal, tell me.
I'm saying the same one.
Okay.
At 1.71 hours to
Okay.
find the reciprocal is basically divided by 1.
And trust me, I'm not a good guy. I can probably add one more tab. Okay. I mean, when I'm saying I'm not a good guy, I'm saying that questions will not remain simple always. But look at this approach. Like I like the way you described Chris, okay? And I'm just adding 2 more cents to it. Now I have one tab which is taking 4 hours, and another tab is taking 3 hours. I'm trying to find out how much time it will take for filling the tank. And the best way to do it is, I have 2 tabs running simultaneously. Let's figure out how much it fills up in 1 hour. Let's say 1 hour, if I figure out that it fills up 5/3 of the tank. Yeah. So all the kids from the junior classes, just hold it for 2-3 minutes. We are almost done, okay? So in 1 hour, how much I am filling up? And once I find it out, let's say if I find out that okay, in 1 hour I am filling up half, then I know clearly, okay, half is getting filled up in 1 hour. How much time will it take me to fill the whole thing? So half is getting filled in 1 hour. So 1, meaning the whole, will get filled up in how much? Meaning I just need to get rid of this 2, and this 2 you can get rid of by moving to the numerator. So 1 into 2. Similarly, now Chris, in your case, you and Vishal, you guys told me that in 1 hour it is filling 1 hour it is filling up 7/12, meaning 7/12 of the tank is filling up in 1 hour. What I need? Only one portion of the tank, one whole tank, meaning I have something like this. So I want to just keep 1 here and move everything else that side. So I say 1 here, and then 12 goes up, 7 comes down, and that is how you guys got 1.7 or 1 or whatever it was. So now why this question was important? What did we do? We just tried to find out the per unit, per hour. We tried finding out the rate. See, we knew that this one is filling in 4 hours, this one is filling in 3 hours. So what was the rate before? 1/4 of the tank per hour. Here it was 1/3 of the tank per hour. So this was the rate. This was the rate for this guy. What did we do? We found out the combined rate by adding them together. So this was a classic example of a rate problem. Yeah. So with that being said, I will let you guys go. Enjoy the rest of your evening, and meet you guys tomorrow again same time. Yep. All right.
Bye, sir.
Bye bye.
Thank you,
Bye
sir.
bye. Bye bye.